In this video, I'll discuss about three topics. One is DataFrame. The other one is Tibble. Tibble is a part of Tidyverse package. So far, I guess this package is not loaded in your system, but I think in order to work with Tibble, you need to load this package, Tidyverse package. You can find Tidyverse here actually. Okay. The third topic would be list. And these are the three other data structure which are also popular, and we would like to see how R actually read these kind of data structures. So the first topic is data frame. So what are data frame? Data frames are typically a two-dimensional data structure, same as matrix. Uh, but in what is the difference between matrix and data frame is actually in data frame, you give names to your columns actually. Okay, and this is important because then you can call individual column by names. uh, you can imagine data frame like an Excel spreadsheet. You have A, B, C, D like columns, and you have rows, 1, 2, number of whatever number of rows this has actually. So data frame in R is pretty similar to Excel spreadsheet. So this is how, and the advantage and the beauty is you can easily work with this data frame. So that's a very important topic in R and very useful data structure in R. So we'll be working with this data frame. What I'll do, I'll just call a simple matrix. I'll make a matrix, and then I will create a data frame out of that matrix. So let me actually identify some variables. So my first variable is state. I'm actually discussing the case of Corona. So I'm taking state-wise cases of Corona, positives, and people who recovered. And the third thing, I'm actually recording the deaths, state-wise deaths actually. Numbers are random because I'm not taking any real numbers, but just to give you an example how you can create a data frame, I'm using this idea. So state, it's a vector. Currently, I'm creating everything as vector, and this vector is Maharashtra, Karnataka, Kerala, UP, then Rajasthan, then Delhi. I'm writing a short form 1, 2, 3, 4, 5, 6. Let me create 10 vectors. Then MP, Gujarat, 1, 2, 3, 4, 5, 6, 7, 8, Punjab, and West Bengal. Okay, so that's my state. Let me read this. I'll copy this and paste in console. Same in console. Okay, and return hit, enter hit. So now the state with 10 characters, this variable is there. I'll call variable 2. Right now I'm saying variable name, variable 2. And this variable is, suppose this is recording the number of number of cases of corona. So 1004, comma Karnataka, which is 230, comma Kerala 456, comma UP 678, comma Rajasthan 345, comma Delhi 555, comma MP 609, comma Gujarat 389, comma Punjab 323, comma West Bengal 299. Okay, this is the variable number 2. What I'll do, I'll run this variable in console, Now variable 2 is appearing here. It's a number with this. Now suppose I'm saying variable, I'm deliberately writing variable. I'm not giving variable name right now because I would like to actually give an example how to change variable name later on once you form your data. Number of cases recovered, 78. Then out of 230, 12, 456, 23, 678, 34, then 29, then 57, then 38, then 24, then 38, 24, 27, and the last one is 19. Okay, this is a kind of picture of number. I'll copy it again. Control C, I'll paste it again. Okay, so you have a variable 3, which are 10 numerical variable, number of cases recovered. Now, the next variable is variable 4, which is basically deaths. Okay, so 78 deaths in Maharashtra, 21 deaths in Karnataka, then you have 39 deaths in Kerala, UP has 67 deaths. All these are random number right now. Rajasthan has 17 deaths. Then Delhi has 87 deaths. Then you have MP, which is 57. Then you have Gujarat, 34. Then you have Punjab, which is 32. Then you have West Bengal, 18. So this is number of deaths which has been reported from. These are random number again, reported from different states. Okay, so we have state, variable 2, variable 3, variable 4. What I'll do, I'll create a matrix. So suppose my variable is y, matrix, or let me, because I use cbind command, because all these are vector, I can bind it, state, var2, var3, var4. So this is, I'll read it in my console, copy paste and return enter. So now this y is appearing over here. Now as I discussed in the last class, y is a character. The structure of y, you can check structure of y, str, y, it's a character. Oh, taking time. Okay, so yeah, it's a character with this is kind of content of the character. Okay. Now what we have done is, so far you have created a matrix. Y is actually a matrix that has 10 rows and 4 columns. Columns are variables. What I can do, I will convert this matrix into Y data, which is a data frame. So I'll type a command as dot data dot frame. Okay. And I'll say Y. You convert Y in form of data frame. That's the meaning of this command. I'll copy this and paste in my console and then done it. Now, if you look at Y data has appeared in my workspace that has 10 observations. Observations are typically rows. This is how we arrange our data actually. A very a standard convention for arranging data is you have to keep observation in rows and variables in columns. So this is how data frame actually prepares data. So it has 10 observations, 10 states which are in rows and variables are in columns. So what are variables? I can click over it, and remember this is a signature for any variable to be identified as data frame. So this is very important. If this is appearing before any data, it means this is a data frame. Now let us look at, I can click over it and I can look at the content. State, which is a factor, variable, which is factor. I said in the last video that I have not defined factor anywhere. So what I said in the last video, what R takes if the variables are not very clear, or define them as factor. What we need to do is we need to convert that factor into numeric so that we can work with the data. So this is what I did last time also. So this factor element is very important in this context. So state factor, variable 2 factor that has 10 labels, variable 3 factor that has 10 labels, 4 factor that has 10 labels. So all this is the content of your data frame. Now if I read this data, I can double click over it and this data frame will appear in my data viewer window where I can say states variable 2. Now the thing is variable 2, 3, 4, there is no name given to these variables actually. So what I'll do, I'll give name to these variables. Okay, so I'll say names, and what is my data? This is a command actually. Okay, so y data, and you specify names. All these names are typically character. When you give a column name, these are character. So you say state comma variable 2 is cases comma variable 3 is uh, recovery recovered that's you recovered, and the variable 4 are deaths. Okay, if I run this command, what will happen? I'm copying it and posting and running in my uh, console. What will happen? Before that, just look at y data. Now variable 2, 3, 4. Let me run the command actually and look at, keep me open. Let me keep it open. I'll run this. Okay. So I'm running this. What it has done, it has changed the name of my column, variable 2, 3, 4. Now I'll double click it again. Let us look at. Okay. Now state, cases, recovered, death. So I can, this way I can change the name of the column. Now, what is an advantage of this giving names to column is I know this variable. So I can call variable and do mathematical operations with variable. I'll show you this in a short while. Suppose, how do I actually get variable? There are two methods. One is by matrix. So suppose I want to get a variable of recovered. So what I'll do, I'll say y data, which is a matrix. Which column is recovered? 1, 2, 3. Third column is recovered. So what I'll do, comma, comma means you take all rows and third column. So I can, if I do this, I can get the cases which are recovered. Okay. These are the cases which are recovered. It is showing label because right now it is reading recovered as, you can look at factors. Okay. We need to convert this into numeric. So I'll write now. What I'll do, let me do the conversion. So recovered. So what I should, how do I convert a factor into numeric? As dot numeric. Then within that as dot character, and then I have to specify my data is comma, sorry, y data square bracket comma 3. That's my third variable actually. If I do this, it will show me a new vector which is recovered. Okay, let's check it. You can look at recovered is appearing here, and it's a number instead of being a factor actually. Okay, this is one way of extracting a particular column from a matrix, because anyway variable names are arranged in columns. The other way of extracting this data is you can call directly y data. So I'll say recovered 1. I'm writing this rec1. You can call your data frame and then you apply dollar sign. Dollar sign is actually used to apply, used to identify the content of your file actually. So in my file there are 4 columns. 4 column has 4 variable. I can identify this. It is much better if I do this in console. So let me copy this part and in console. So why this is useful? Because if I put a dollar sign, R will start prompting me, and I can pick out something from the prompt actually. That's the best way actually. Okay, R is not prompting. If R is not prompting, what you can do, you can actually put a tab button, hit a tab button. Something is wrong because I have written this wrong Y data. Okay, now if I hit a tab button, it will give me options, which are the content of. This is important when I can select anything. This is very important when you work with a very large data, a huge file actually, because sometimes the data frame has huge, very large character content, and then the name of the column is defined by a large character actually. So then you can choose your individual column by using this prompting actually. This is very useful. If prompting is not appearing, what you should do, you should hit tab button. Okay, once you're hitting tab button, you can say, so I'm choosing recovered. Now this is REC1. I'm reading this into REC1, hitting. So you look at REC1. REC1 is the factor of these variables. Okay, so this is how you can read the content of your data frame actually. So this is very important part of date R structures. I'm not converting factor into numeric, which we have already done. And if you want to do any mathematical operations, we can do this. So the idea is what we have done, we have created a random data frame. We looked at how to call the content of individual variable from the data frame. Later on, what we can do, we can actually use this and to do some kind of data and actually use this in a data analysis. So this is the first important data structure in R. I'm going into the second important data structure in R, which is Tibble. Tibble are typically, they are nothing different than data frame. They are actually a data frame. But they been designed, and this is what is a kind of new development in R. They are designed to take care of very large data set. If your data frame is very large, and it is a bit harder to print it, because if you have a data frame like 1,000 variable and something 10,000 rows, if you have this kind of data frame, it's a bit harder to print in the window actually. So what people have actually done, they have designed this new function Tibble, and using Tibble, what you can do, you can print a large data set in the limited size of your window actually. So you can easily you can also look at the structure of your data. Since my data set is not very large right now, what I'll do, I'll simply show you how this Tibble function works. And in the next class, I hopefully will start working with and taking data from other sources. Will not be creating data. We'll import data from sources. Then possibly we'll look at the advantage of Tibble. But at the moment, if you want to work with Tibble, there is a requirement. You have to have a tidyverse package. Okay, how do you get tidyverse package? You have to type a command, library. That's a command to call any package I discuss in the package part, and you say tidyverse. Okay, this if you run this, okay, let's run this. Run selected line. If you run this, what will happen? Tidyverse package start working in my system. It may be installed earlier, but if I don't call this library tidyverse, the package will not work. So in order to make the package working, I have to call this command library tidyverse. And then suppose what is my data frame right now? My data frame is Y data. Okay. So let me say xt, sorry, that's my mistake, xt. And I say, okay, xt is as I'm converting xt because yt is a data frame, xt is Tibble. So as underscore Tibble, okay, that's a command function, and y data. So I'm converting y data, which is data frame, into Tibble. Let's check it how it happens. Unselected lines. Now what is happening? This is running this part. Y data is the data frame. XT is the Tibble. Tibble is also shown by this play button. Okay. You can click over it. You can look at the content of the Tibble. Now let us check the structure of Tibble. XT. So XT is a Tibble that has 10 rows, 4 columns, and it has $state1. These are the variables. Cases, recovered, deaths. So this is how you convert your data frame into Tibbles. You can print Tibble by simply clicking ST and running this. I'll do this directly in my console. So let us look at how Tibble looks like in console. And this is your Tibble actually. So you can go with a Tibble, state, case recovered, cases recovered, death, and then it tells you what is the structure of individual variables. So it is factor, this is factor, this is factor, and this one is also. You can also double click over here, and you can get the same structure as data frame actually. Okay, so as I said, Tibble is not different than data frame, but Tibble is a useful function when you work with a very large set of data actually. So currently you won't find any difference between your data with the data frame that you have created and Tibble, because the data set that we are working is very small. But suppose if you take a large data set, then Tibble is a useful function in that case. So we'll be discussing about Tibble later on when I import large data actually. Okay, so this is the second important structure of data. And the third or most important structure in R is list. So we'll talk about list. So what are lists? List is just like you can imagine you're buying apple, oranges, and you're buying vegetables, and you want to put everything at one basket actually. So list is the same thing actually. You are actually creating a lot of data set, okay, and you would like to put every data, all these data with a different structure actually. So you have a different data set with different structures, and you want to put in one basket actually. So that is what that basket in R is known as list. Okay, so you may have vector, you may have matrix, you may have data frame or table, and you're putting everything into, or even a scalar value, you're putting everything into one basket. So lists are typically this kind of arrangement. Because if you want, I want to put different matrix into one matrix, the conditionality is that matrix should have same size, rows and columns. List doesn't require this conditionality. If you have 4 or 5 matrices with different sizes, it can work with that actually. Okay, so let us look at how this list part works. I have already one data frame, Y data I have already. Let me actually create another data frame. So if I look at matrix, I'll just click over it. I have a Y matrix. Let me uh, uh, filter this matrix. Take only 6 variables. Okay. So Y filt is my command, and this Y filt is taking a Y matrix, only 6 variables, 6 rows. Okay, 1 to 6, and all columns. Okay, so this is one variable Y filt. Y filt, 6 rows, all columns. Suppose I have another matrix X filt, that's a different size of the matrix, and it has all 10 rows but only 2 columns, 3 columns. Okay, so Y all rows but 1, 2, 3 columns. Okay, this is the third data set. Okay, this is the third data set. So I have X field, I have Y field, I have a Y data actually. So these are the 3 different data set. Plus I have some vectors. Okay, var1, var2, var3. I can pick up anything. So suppose I want to keep everything. I want to store and everything. Okay, how would I store? I'll call variable something, you can call it like X list, okay, which is a list of, sorry, LIST, spelling is wrong, which is a list, and that has 4 data set. One is a vector, and my vector is var 3. I'm storing my vector. In my vector, I'm storing variable 3. Then I have this X field I'm storing. This is only 3 variables: state, cases, and recovered. Okay. So I'll say met1 underscore, so that I can identify this. I'm giving this name actually, met1 underscore 3 vars. Okay. That's a name. And I'm storing this in X field. Okay. Now, the next variable which I have is Y field. So that is a met2, and it has 4 all calls, or 6 observations, 6 ops. That's a name which I'm giving here. So this is Y field. Then I have another data frame, data F. Okay, that's a name which I'm giving to my data, and Y data is my data frame. Then I have a variable Tibble. Okay, I'm storing this table into XT. What I can do, I can store everything. I'll run this command, which is a list of all data sets. Okay, let me run that. Now, if you look at this, X list is appearing in your workspace environment window, and also it is showing a play button. Play button is also used for list data, because you can call individual data. That's why there is a play button. You can call vector, matrix, matrix 2, matrix 3, everything you can call again. Okay, so this way you can create variety of data set you can create within one basket, which is your list. Now, suppose you want to call an individual variable. Suppose I want to call a data frame. So X data F I want to call. So I'll call list, LIST, and put dollar. Now it is not prompting because I'm working in notebook. I can directly go to my console. Let us look at X data frame, which is X list. Then I'll put dollar. So it will again prompt me the content of this list actually. Okay, it means it has vector, met1 3 var. These are the names which I have given. Met2 6 ops, data F, Tibble, or something. I can pick up Tibble, can run this. So it will be X data F. It is showing me a Tibble. I can look at. Okay, it's showing me a table. I can look. Okay, a table of 10 into 4 variables. So this is how list can be created and can be called. Now, what is an advantage of list is, suppose we are writing a very long, lengthy data analytics program. What I can do is I can store my data in list, and then I can call it again and get all the content of my data. That's one advantage. In many cases, like in our packages as well as in our functions, what happens, the outputs of your functions, I described how function is created in the previous videos. So what you do, you have a multiple output of a particular function. And how do you actually store all these multiple output? You create a list and you can store these multiple outputs. So many functions in R take list as of storing output actually. You can work with your data, but all output will be, that's why you can look at the column says values. So all outputs are stored in form of list. Okay. In order to give a kind of application of this function list, I'll actually take one very useful command or data analytics command, which is a very short form of linear regression. Now, suppose I would like to know what is the relationship between number of cases versus number of uh, people who got recovered. The first easiest way is to give a plot. Okay, so how do we plot? And I have a data frame y data, capital data, and my variables are number of cases versus number of recovered. So I'm keeping x-axis is my number of cases, comma y data dollar number of recovered. I'm keeping this. I'll can what I'll do, I'll actually run this command and my plot will appear. Now my plot window will be activated and it's appearing actually. Okay. Now this is not the correct plot. Why? What is happening? Because all both X data cases and recovered are right now functions. Oh, sorry, factors. So I have to convert them into numeric so then I can get a very appropriate plot. So I'll say as dot numeric, then within this as dot character and my X data cases. Okay, so this is converting into this, then as dot numeric. It looks like little cumbersome, but this is a very important step. This is what I was discussing in the last video. I have to convert this. Then x dot numeric. Within this, I have s dot character, character, character. Okay, and then this is closing the window for s dot numeric, and then it is closing the window for plot. Okay, this closing is very important. Now, if I run this, it will be showing me the plot actually, which has number of recovered versus number of cases actually. Okay, now this is the first way of looking at your plot actually. Let me actually read this variable x as x1, okay, and the next variable as y1, because then I need to, I'm not converting this right now, I'm copying it, copying and pasting it. So y1, okay, and let me actually run a regression between what is my independent variable. I'm keeping number of cases here. What is the idea is to look at what is the relationship between number of cases versus people recovered actually. Okay, how do you run a regression in R? There is a very simple one-line step in R is you actually, I want to store the variables into, so basically the way of running regression is LM, okay, and then I have to specify my dependent variable. What is my dependent variable? Number of people recovered. Then I have to use the tilde sign and people with the cases actually. So you have to have dependent variable and then independent variable. Okay. Now what I do, it will actually give me a output in variety of forms. So what I'll do, I'll store this output in a particular object. I'll call this object as H. And I'm storing everything into H. So if I run this, okay, take this, run selected lines, y1 not found, something, oh, sorry, I'm sorry, I've not run these two actually. Okay, run these two also, okay. Now you run this. Hmm? So what is actually happening, still not running this, let me run it again. Okay, this has run. So your regression is running. So what is actually happening? All the output of your regression is stored in a object H, and if you click over it, these are the outputs: coefficient, residual, fx, rank, filtered values, assign, QR, pivot, TOL, tolerance, rank. Okay, all these are, it's because if you want to know the regression in detail, every parameter of regression is stored in this output. And this output is actually a list. You can look at strh. Okay, it's a list which has so many content on it actually. So this is advantage of making lists. All the functions in R are actually list of 12 different outputs actually, or 12 objects actually. So this is how R takes actually list. It can store different output into a list. Okay. Let us look at how this regression is performing. Okay. though it's not a part of this continuity, but let us, for the time being, I can examine. So I can call summary and then look at the summary of H. Okay. So this is the output, summarized output of my regression actually. Okay. So this regression is saying there is a relationship between a strong relationship, though we have inputted the numbers that we have inputted into the data frame were random, but by chance, whatever it be, we got a very strong relationship between number of cases recovered to number of cases of corona, positive cases, and my R square is 0.7644. My p-value is 0.005767. So this is, I'll discuss this part later on in detail when we discuss about regression, but just to show you how R takes this element list. List is very important variable because most of the R functions, they store their output in forms of in form of list. In the next, so this is all about this video. In the next video, we will discuss about how do we import data into R, and I will actually, before discussing on this part, how do I import data from outside sources, I will actually send you some data so that you can have these data set beforehand when you look at the video, and you can actually work with me work with me when I'm discussing in the video. You can also start side by in your laptop. You can work with that with this data set. So this is all about this video. Bye bye.